All right, in Chapter 11, we're going to look at intermolecular forces and then specifically at liquids and solids and then the forces between those types of matter. So let's look at the first section, which is we're going to compare gases, liquids, and solids, and we spent an entire chapter on gases. So we're going to, again, look mostly at liquids and solids here. Okay, it says many substances that are in the liquid and solid phase are molecular compounds, and they have what we call covalent bonds. Remember, that is where you're sharing electrons. We've got nonmetals and nonmetals bonding together. The physical properties of molecular liquids and solids are due largely to intermolecular forces, or forces that exist between molecules. Remember, intermolecular, between two molecules. Okay? So let's first look here at liquids and some characteristics of liquids. Okay, liquids are more dense and less compressible than a gas. That's because these particles are closer together. Okay, they are closer together because the forces are stronger than in a gas. So the bond between, or the force between this molecule and this molecule is a lot stronger when it's in a liquid form, so that's why they are a lot closer together. Okay. Liquids can be poured because the forces are not strong enough to keep them from moving past one another. So they're stronger than a gas, but not so strong that the particles eventually can't move and slide around. All right, so that's a liquid. All right, now looking at a solid, these are not very compressible. Okay, they have very little free space between particles. And these forces are actually strong enough to keep them very close together in these particles, and then kind of locks them in place. Solids, remember, do not really flow, okay? So those forces are very strong, keeping it together. Often solids are called crystalline structures, okay? These are the ordered 3D arrangements, and you have a picture there kind of right below to the right that has a crystalline solid. It's an orderly arrangement. They're fixed, okay? Again, these are where your particles don't move past one another, but they do vibrate in place. Okay, so the state of a substance depends on the balance between the kinetic energy of the particles and the interparticle energies of attraction, meaning it's a balance between how fast the particle is moving, how much energy it has, and then how much the energy between two particles is trying to keep it together. So is the force trying to keep it together stronger, or is the force and the energy that the particle has more, so it's going to leave? Okay. Remember that kinetic energy depends on temperature and keeps particles moving. If you have a change in temp, then you have a change in energy, and your state can change. If your temperature decreases, the kinetic energy decreases, and the attractions between molecules pull them together. Remember, you're looking at the balance of the kinetic energy of the particle, okay, compared to the energy keeping the particles together. And you see an example there of your gas, liquid, solid. Okay, gas particles are totally disordered. Your particles have lots of energy, so the force that's keeping them together is a lot less, so they move around a lot. A liquid is a little more in between. It has a stronger force of attraction between particles compared to the particles themselves because they're not moving as much anymore. They don't have as much energy. Whereas in a solid, they have even less kinetic energy. So the energy between particles is the one that wins, and they stay locked in place. But they still do move a little bit when they vibrate back and forth.